So this is a description, a visual description of the roles and steps in the process. Our 5-step process at Live Green is a version, if you like, of this 6-step kind of template process. You can see in the right-hand side there, step numbering, which it roughly sort of is the same as when I was an architect, having a plan of work from inception at the very top, getting an idea of the intended outcomes of a project through an initial risk assessment and an evaluation of what the brief is, and then moving into actually surveying the properties and providing options for their improvement, energy efficiency, upgrading, and along the way, advice about planning and building regulations, and then finally into design. Always getting the client's approval along the way and drawing them in. And then you go to the building, step 5, and then you go to the monitoring and handing over, which is step 6. Brings us to the central philosophy behind design philosophy, effectively behind PAS 2035, which was set up to ensure greater accountability from design and installation of measures to avoid certain unwanted consequences, which is very easy to do when you upgrade an uninsulated or poorly insulated building. And the primary philosophy is called Fabric First. So I generated this sheet to highlight this idea of fabric first. I pithily included the idea of services second and energy at the end to highlight that there are basically 3 food groups. You're prioritizing what you can do to the building's envelope, as windows, doors, walls, ceilings, floors, roofs, to improve the heat loss with insulation. Generally doing that improves your SAP rating, but it also reduces heat demand. For a lot of social housing decarbonisation fund awards, hitting both targets for SAP rating and a reduced heat demand go hand in hand, although they're not tied to each other, because they can't be really. SAP ratings can be improved by different measures in different ways. But if you're going to alleviate fuel poverty, if you're going to remove carbon effectively, if you're going to preserve the building's serviceable life, if you're going to improve internal air quality, if you're going to reduce psychological stress, especially the threat of not being able to meet your rent because of difficult energy costs, then prioritizing insulation is a sort of no-brainer. But it's extreme, of all the 3 measures, types of measure that you can install, it's usually the most disruptive, and so requires the most work and is often more expensive as an option when thinking about that. So it really begs the question, thinking about fabric, whether or not you're going to be investing long-term for a project. And really the cost generally of fabric is going to lead you over a sort of mortgage length period. So it's a proper investment really to be thinking about.
External wall insulation is typically characterized as an insulation layer attached to an existing wall, to the outside of an existing wall. It protects the wall from weather and will be protected itself from the weather with a coat of render or an alternative cladding, such as adhered brick slips, tiling, or even timber board cladding. It's frequently used to insulate walls on properties where cavity and internal wall insulation is either not an option or does not in itself reach your desired SAP rating. You can't apply EWI to a wall, a cavity wall, without having first filled the cavity. You have to, because you're changing the dew point of the wall and you need to remove that air gap. So this also helps keep the impact of external wall insulation, which obviously is going to add bulk to the existing building size to the minimum possible. While adding insulation should seem like a no-brainer to increase your house's thermal efficiency, no type of wall insulation, including external wall insulation, comes without some form of issue, often based on how your home already deals with moisture. You normally, with EWI that's being applied to domestic social housing projects like ours, is going to be a fully adhered build-up of insulation bonded to the existing wall with no air gap, and then over rendered usually or covered in adhesive and brick slips, which themselves are fire rated. So it's a EWI, as we generally understand it, as a different experience to overcladding an existing tower block.
So some of the challenges that we come up against on a fairly regular basis, and probably were reflected in the questions in the poll just now, there's a lack of understanding from developers, people in retrofit, dare I say, end users, developers, anyone and everybody, where there's a lack of understanding of potentially what is a suitable renewable heating system for a building, which systems might work together integration-wise, how they work, what the costs are, what the implications are. There's a lot of misinformation. That barely a day goes by without some sort of hysterical article about how heat pumps don't work or are wildly expensive or this, that, and the other. They don't work in winter. So the list goes on. So there's an awful lot of that out there. A bit of fear and negativity around that, based probably upon all that misinformation and the stuff that gets out that, you know, a bad experience here and there can highlight. The skill set of the workforce, as I touched on earlier, you know, we're working with currently a very, very mature marketplace where there's an awful lot of guys out there who are able to work on the existing fossil fuel technology. Whilst it's still a heating system, this newer technology has some challenges and some design factors that are slightly different. So the workforce and the skill set required perhaps isn't quite where it needs to be as yet. So that's a huge work in progress. We're talking about switching to low temperature heating, and that has there are implications around that for the existing housing stock that we have. Some of what Andy's presentation touched upon in terms of solid wall buildings, old buildings without cavity wall insulation, without any insulation. These all have an impact when you're switching from a very forgiving high temperature system over to a low temperature heating system, such as a heat pump. We've also got the challenges around the cost of electricity versus gas or oil, and have historically had that. As we're trying to move towards the electrification of heat, clearly we need to be in a position where the costs stack up as well. So there are conversations to be had around that as well. So just very briefly looking at where we're going in terms of carbon savings, from the left over to the right hand side here, you can see where we're talking about ending up with the projected use in terms of carbon savings once we get towards air source and ground source heat pumps. Already with the grid provision as it is, we're streets ahead of gas, oil, LPG, etc. As the grid cleans up and as the electricity that we use to power these appliances is also cleaned up, we're in sort of really, really positive territory and moving towards where we want to be. So there are massive carbon savings, as I've already said, associated with air source and ground source heat pumps. So heat pumps utilize what is already present in the air. They are making use of thermal energy freely available in the air and moving that into the property. That's a very rudimentary sort of picture there of the refrigerant cycle that things go through. The outdoor unit contains a gas called a refrigerant, and when the pressure of that gas is increased via that compressor, the temperature increases. So when the temperature increases, we pass that through, it goes through the system, through a heat exchanger, passes that onto a secondary side of that plate heat exchanger, which exchanges with hot water into the property. That whole cycle then repeats. We release the pressure, there's a decrease in temperature, and the refrigerant cycle continues on and on.
Dangers of an incorrectly installed solar panel system. So just as a bit of an interlude to that, so some stats recently we're just looking up. So in 2022, the fire and rescue services attended on average around 10 solar panel fires every month, and that was up from 7 per month in 2021, and 2021 was up 12% from the previous year. So as you can see, there is an increasing amount of fires from solar installs. This is obviously reflected in the volumes of installations that are being carried out currently. So I think we're on track at the moment in the UK for around 17,000 panels installed a month, and that's looking like that will increase. Solar panels are, whilst there is, we often see it in the news of fires, they are generally considered to be very safe, and research indicates that they pose far less risk than just most common household appliances like toasters and washing machines. However, as I mentioned, the increasing amount of insulation going on, there have been a few cases of fires related to the actual installations, and it's we just thought we'd put some sort of key points on there to social landlords or local authorities looking to roll out installations across your housing stock, making sure that things are done right, to ensure that this risk is mitigated and eliminated in your installations. So with actual solar panel installations, obviously it generates electricity, so that electricity can be used for your household appliances and any other electrically powered item in your property. I put 3 items there, which is the sort of 3 most popular products that we are installing across our projects. There are other options out there, but this is something that we see installed on a more regular basis, and these are all items that can be paired with your solar panel installation, so that you are starting to use the energy you generate